Let's dive right into this explainer. Today, we're going to meticulously decode a seemingly terrifying block of Python code step by step. If you've ever stared at a wall of programming logic and felt your brain just immediately shut down, hey, you're in the right place. We're taking a raw, unedited piece of Python designed to validate an IPv4 address, and we're breaking it down so thoroughly that by the end of this, you'll be reading it like a plain English sentence.
I mean, really look at it. If you're an absolute beginner, we totally understand that seeing complex code syntax can induce instant panic. It just looks like a random, chaotic mashup of slashes, brackets, and numbers, right? When you're just starting out with regular expressions or regex, hitting that brick wall of confusion is so common. But take a deep breath. It is not magic. It's definitely not gibberish. It's just a highly specific, very logical set of instructions.
Just take a look at this specific string from our source script. I mean, it honestly looks like someone just smashed their hands on a keyboard. It's super intimidating, but I promise you, we are going to make this completely readable. This single line right here, this is the absolute heart of the program we're analyzing. It does all the heavy lifting, and once you understand the tiny individual building blocks hidden inside those quotes, the whole mystery is just going to evaporate.
So, to avoid cognitive overload, we're following a super clear roadmap today. 1. The IPv4 problem. 2. Meet regular expressions. 3. Decoding the octet. 4. Assembling the pattern. And finally 5. The Python wrapper. Let's get into it. Part 1. The IPv4 problem. Before we translate any code, we actually need to understand the real-world problem this Python script is built to solve. So, what exactly is an IPv4 address? Simply put, it's the digital address for a device on the internet, and it has a very strict data format. It always consists of exactly 4 separate numbers, and those numbers are separated by periods, or dots. But here's the absolute critical catch. Each of these 4 numbers can't just be anything. They must range strictly from 0 up to a maximum of 255. So our challenge here is figuring out how to get a computer to automatically check if a user's input perfectly matches this exact, totally unforgiving number format.
Which brings us to section 2. Meet regular expressions. Because to solve this problem, our script imports are a remarkably powerful tool.
I want you to think of regex like a bouncer at a super exclusive club. This bouncer has a very specific list of rules about who gets in and who gets kicked out. When a user types in an IP address, they're basically handing their ID to the bouncer. By importing the re-module into our Python script, we're basically hiring that bouncer to validate the user's input. And listen, this bouncer does not care if the data almost looks right. It strictly checks the data against our criteria, and if it is off by even a single character, no way, it gets rejected.
Moving to section 3, decoding the octet logic. Now we need to tell our regex bouncer exactly how to spot a valid octet, which is just that number between 0 and 255.
Okay, let's stop right here. I want you to treat this like you're learning a brand new language, because these are the core symbols our script uses to build its logic. Think of this as your absolute beginner's translation guide. First up, the \d. This simply stands for digit, literally any single number from 0 to 9. Next, that straight vertical bar. That is the OR operator. It just tells the computer, hey, match this rule or that rule. Third, we have the square brackets. These define a strict range for a single digit. Like if you see 1 through 5 in brackets, it means a single digit that is 1, 2, 3, 4, or 5. And finally, the question mark. This is a wildcard. It says the character right before it is completely optional. Might be there, might not. Just keep these 4 little translations in your back pocket.
So the crucial point here is that the OR symbol, that vertical bar we just talked about, it actually separates our giant, scary string of code into 4 completely manageable, distinct logical statements. Our regex is just checking 4 separate buckets. First, it asks, is the number between 250 and 255? If not, or is it between 200 and 249? Or is it between 100 and 199? Or is it between 0 and 99? If a number fits into any of those 4 buckets, boom, it's a valid octet. Let's look a little closer at exactly how it writes those rules.
Let's look at our highest ranges and see how this actually builds. On the left, we want to allow 250 to 255. The code says 2, 5, followed by a 0 through 5 in brackets. That literally translates to find a 2, followed by a 5, followed strictly by a digit between 0 and 5. It mathematically caps out at 255. Now glance over at the right side for the 200 to 249 range. The code is 2, then a 0 through 4 in brackets, then \d. This means find a 2, followed by a digit between 0 and 4, followed by our \d, which, remember, means any digit from 0 to 9. So that perfectly covers 200 all the way up to 249. Make sense?
And this is where it brilliantly illustrates how the code handles lower numbers. On the left, for the 100 to 199 range, it uses a 1 \d \d. Simply, a 1 followed by any digit, followed by any digit. But check out the right side for numbers 0 through 99. It uses that question mark. It says, okay, you might have a digit from 1 to 9 first, but hey, it's completely optional. Then it absolutely must end with any single digit. This is so cool because it seamlessly validates a double-digit number like 45, or even a single-digit number all the way down to 0.
All right, Section 4, assembling the full pattern. We know how to check one single octet now, so let's zoom out and see how the script handles all 4.
The script builds a final pattern using some really clever structural boundaries. Step 1 utilizes a physical start line anchor, which is represented by that little caret symbol. Step 2 simply injects our decoded octet variable 4 separate times, separated by literal dots. And Step 3 uses the $sign as a strict finish line anchor. Those start and finish lines are absolutely crucial. They ensure the bouncer evaluates the string exactly as it begins and exactly as it ends, so there is literally zero room for any extra hidden characters sneaking in.
Just look at how clean and simple the pattern variable looks now that we actually understand the building blocks inside of it. It translates perfectly. Start here, check for a valid octet. Then, notice the \, right before the dot? That just tells the bouncer we want a literal period, not a regex wildcard. Then another valid octet, literal dot, third valid octet, literal dot, fourth valid octet, and stop right there. What once looked incredibly dense is honestly now just a totally logical map.
Finally, Section 5, the Python script wrapper. Let's see how Python wraps around our regex rules to actually function as a full program.
The script uses two main functions, main and validate. It simply asks the user for an address through an input prompt. It takes whatever they typed, passes it directly into our validate function, where our regex bouncer is standing by with the exact rules we just decoded, and then it just prints out whether it was a match or a rejection. It is just beautifully efficient.
If you've been following along, you've hopefully just experienced a massive aha moment. By breaking things down meticulously, you've transformed a terrifying string of absolute gibberish into totally logical, readable instructions. You've looked right under the hood of how computers validate the very structure of the Internet's addresses, and you did it simply by translating symbols into plain English. That is huge.
So, armed with the ability to break down and decipher complex logic piece by piece, I really encourage you to seek out and translate the next seemingly unreadable piece of code you stumble across. It is not magic. It's really just a puzzle waiting to be solved. Think about it. If you can read the bouncer's rulebook now, what other hidden instructions in our digital world can you begin to decode? Keep that curiosity alive, keep decoding, and keep